All right, we have proven that if you know it's a parallelogram, then the opposite sides are congruent. In fact, we just stated that a moment ago. What we're trying to do is prove that if all you knew was that both opposite sides were congruent, if that would be enough to prove that it's a parallelogram. So that's kind of cool. We'll see if we can go backwards. So we're going to be given that both sets of opposite sides of the quadrilateral are congruent, and we're going to try to prove that it's a parallelogram. So we'll go ahead and start with our original that we had. Both sets of opposite sides of a quadrilateral are congruent. So that is our given. And what that means specifically is that AD is equal to BC and that AB is equal to DC. And the reason I know that is I know that that is the definition of opposite. So these specific ones and these guys here. Now, parallel lines. The basic way of proving parallel lines is to prove that we have some sort of alternate interior or corresponding or something that is true. So we don't have any of those yet. And we don't have any degrees or anything, so we're going to need to add in an auxiliary line. Now, don't want to go crazy. You never want to add a bunch of things. You're just going to start with a little and see if that's enough. If I were able to prove that these two triangles are congruent, and I hope you can see that that's like a half a step away, then I could show that these angles would give me these sides, and that these angles will give me those sides. I'll help color code that in a second so you can see it. So that is all we're going to need. And so I'm going to draw AC. Now, I do not need to be specific about how I drew that because all I did is I connected them. So that is not like the other proof that we did today here. And so in that, AC is equal to AC. And I mark it. And I've got my two triangles, right? SSS. So triangle ACD. And triangle CAB. So again, as long as these guys are in the same location with each other, you guys are fine. So I'm going to add in some numbers here just because it will life will be a lot easier. Those two are going to be important to me, and these two are going to be important to me. So I'm going to want to show that 1 and 2 are equal, and I also want to show that 3 and 4 are equal. Now, why are they equal? Because congruent triangles give me congruent parts for both of these, which tells me something. So, these angles here are a part of this Z, and these angles here are a part of that Z. So, I will be able to say that AB is parallel to DC and AD is parallel to BC for exactly the same reason. Alternate interior angles that are congruent to each other give me parallel lines. So again, that one gave me that, and that one gave me that. So that should do it.